Hello students and welcome back to my channel. This time we are discussing questions based on semiconductors and communication which were asked on the 1st of February 2023 JEE mains. So without wasting time, let us discuss them one by one. So question 57 is you have a match the type column, you can see. Left hand side there are some concepts related to semiconductors, right hand side something related to them. So we have to match them. Now you can see Fermi level. List 2 has Fermi level. So Fermi level is the energy level corresponding to electrons in at 0 Kelvin. That is absolute rest. Okay, you might be knowing that at absolute rest the energy level is not zero. Unlike many students think that at absolute zero everything comes to a standstill. Of course not, because electrons keep moving. So the energy level corresponding to absolute zero is known as Fermi level. Now in intrinsic semiconductors, it lies in the middle of valence band and electron band, valence band and conduction band. So A should be mapped with 2. Then in metals, they lie well inside the conduction band. So D should be mapped with 4. Now in case of N type, so suppose it's the conduction band and this is the valence band. Okay. Conduction band can be shown with the help of certain electrons here. Valence band can be shown with the help of holes. Of course, electrons will also be there. Okay. And in conduction band only electrons will be there. So this is known as forbidden energy gap, or simply you can call it as forbidden gap. Now in N type, the Fermi level will be close to, in N type it will be close to conduction band, whereas in P type it will be close to valence band, Fermi levels. So N type will be Fermi level is near the conduction band and P type Fermi level is near the valence band. So the option is the correct option. Then which of the following frequencies does not belong to FM broadcast? Now here students, you have to remember the range. Okay, for FM, that is frequency modulated broadcast, you have to remember this range. It lies somewhere around 88 million hertz to approximately around 108 million hertz or megahertz. Okay. So the only frequency which lies outside this range is this. So you have to be careful. Then coming to question 59, in an amplitude modulation, a modulating signal having amplitude of X voltage is superimposed with a carrier signal of amplitude of Y voltage in first case. Then in the second case, the same modulating signal is superposed with different carrier signal of amplitude 2Y volt. The ratio of modulation index in the two cases. Now students, modulation index is nothing but, in such a case, for amplitude modulated wave, it is just amplitude of the modulating wave upon amplitude of the carrier wave. That's all. Okay. Now since you can see that the same modulating signal is superposed, so this is same. So we can write modulation index varies inversely as the amplitude of the carrier wave. So modulating index or modulation index in the first case to that in the second case will be carrier wave amplitude ratio in the second case to the first case. So this will be 2:1. B option is the correct answer. Then moving to question 16, choose the correct statement about Zener diode. You know students, Zener diode is one which operates in reverse voltage. Okay, it is always operated in reverse voltage and it has several applications. The main application of which is voltage regulation. So it works. A option reads, it works as a voltage regulator followed by a strong. it should work in reverse bias only. So B option, it works as voltage regulator in both forward and reverse bias. Now it works as voltage regulator in reverse bias, behaves like a simple PN junction. It is correct, students. In the forward bias, it is simply an ordinary valve or an ordinary diode valve. However, in case of reverse bias, it will certainly behave as voltage regulator. So C option is the correct option. D is anyway wrong. It does not work as voltage regulator in the forward bias. So that's all, students.